Okay. All right, this is going to be your ideal gas law notes. The ideal gas law is PV equals nRT. P is for pressure, which we already have used equations with pressure in it. V is for volume, which we have already used. T is for temperature, which we have already used. Okay. The two new variables are here. N stands for moles, and R is your gas constant. Okay. So let me take a minute and explain that. You're going to have three available gas constants: 62.4, 0.0821, and 8.314. Let me explain the difference between these. They all have the same units, and this is what it is, okay? Liters. And then down here, it's moles times Kelvin. That's our temperature. This one, the only difference between all three of these, and I'll go ahead and write it out for all three because their units are the same except for one thing that I'm going to show you. Remember, these are just units over here. It's just the units for each gas constant. The only thing different is the pressure units. So you're actually going to be able to pick which gas constant you want to use in your formula based on the units of pressure. Okay, so this top one is mmHg, right? That's one of our pressure units. This one is ATM, and then this one is kPa. So if they gave you your pressure in kPa, you would want to use this gas constant N for R. If they gave it to you in ATM, you would want to use this constant N for R because it would match up to your pressure units. All right. Now, the only one little difference is that before you guys could use milliliters as your units for volume, as long as it was the same on both sides. That's not the case with the ideal gas law. Your volume has to be in liters. So every time you get a problem, you got to make sure that the volume is in fact in liters. Now, let me show you really quickly if it's not in liters. Let's just say they gave you 200 milliliters. And you know that when you use the ideal gas law, it needs to be in liters. It's very simple. If it's in milliliters, to put it in liters, you simply go 1, 2, 3. You move that decimal 3 places to the left, and that would be 0.2 liters. Okay, it's an easy fix, but just make sure that you have it in liters for all of your problems. Okay, if they give it to you in milliliters, you got to convert it. All right. All right. So let's work a sample problem. First one, how many moles? So let's listen. For every one of these, you're still going to need to list out your givens. So we're going to have a pressure, a volume, an N, an R, and a T for each one. Okay? So this is number one up here. This is the one I'm looking at right here. It says how many moles. So that means I'm looking for moles. Remember, N is moles now. That's one of our new variables. Does it take to occupy 120 liters? Okay, that's a given, and it's in liters, so I know that's my volume, 120 liters. At a pressure of 2.3 atm, so that's going to be our pressure. All right, and a temperature of 340 K. So that's fortunate. It's already in Kelvin. We don't have to convert it. It's ready to go. Now, they are never going to give you the R in these problems. You're going to have to pick your own R, all right? And it's going to be based on the pressure unit. So see, my pressure here is ATM. I'm going to match it with this right here. That means I'm going to use this R right here, 0.0821. That's how you pick your R. It's always going to be one of these numbers right here. Okay? And then the easy part, you just plug it in. So here's my formula right here, right? So for P, I've got 2.3. For V, I've got 120. And absolutely work this out with me. Get your calculator, everything you have to make sure you're doing it correctly. We don't know N, so I'll just rewrite it. We're going to use 0.0821 for R, and we're going to use 340 for Kelvin. Okay? I know that you guys like to combine like terms. So before you start solving for your variable, if you want to combine these guys, you can go ahead and do this. You can say 2.3 times 120. Okay, so these two combined is 276. You can go ahead and combine these two. So 340 times 0.0821 is 27.914 N. Okay, I just rewrote N. So then all you have to do is divide over, right? Our unknowns here, so you always divide away from the unknown. So 27.94 divided by 27.94. Okay, so N equals 276. Okay, 9.88 moles. So put your units in there. I know I had to kind of squeeze mine in there, but make sure you do your units, okay? Don't forget. All right, so I may be able to just undo most of this. Let's see. So we can do our other problem. All right. As far as it lets me go, that's okay. I'll erase the rest. All right, so that's for that first problem up there. I wanted to show you a couple of different things that they can do to you with these. So I've got you a few examples here, and these are for your notes. You can use these on Friday on your quiz. Give me just a second. It's just easier to do these all in the same spot and erase than to rewrite them every time. So just give me just a second. Stray mark there. All right. For our second problem, all right, it says a sample of 1 moles. All right, so that's our N. That should tell you right there, okay, that's N. That's moles. It goes right there for the N. Okay, at 50 degrees Celsius, so I'm going to go ahead and write 50 degrees Celsius. And, you know, right now, I'm going to go ahead and just convert that to K, which while we're thinking about it, we don't want to forget. So 50 plus 273 is 323 K. Okay. And then 98.6 kPa, that's going to be your pressure. So 98.6 kPa. Okay. What volume? We are looking for volume. Now, again, we do not have an R. That's normal. You have to pick the R. Okay. If the pressure is in kPa, we're going to pick the R with kPa in it right here. All right. So we're going to use this R this time. So 8.314. Those R's are never going to change up there, all right? You're going to use them every single time. Okay, so then we just plug in. So for P, we've got 98.6. We don't know our V. Our N is 1. Our R is 8.314. And our temperature is 323. All right, again, I know you like to combine like terms. So 323 times 8.314. If you want to go ahead and combine these, in the 1, I mean, it's just 1, so times 1 is 2,685. I highly encourage you to do this along with me on your calculator so you can make sure you're getting the same thing as me. All right. Last step is to divide over 98.6. You always divide away from your unknown variable. So it could go either way. It just depends on which side your unknown's on. Always divide away from your unknown. So divided by 98.6. All right, so the answer, volume, equals 27.2. Now, our units for volume are always going to be liters every single time. Okay? If they're not in liters, you got to put them in liters before you use them. All right? You see how much I can get done with the undo button. Okay, about that much. Okay, we got one more, and I really wanted to show you one like this last one because it involves them giving you a mass for your moles, but I'm going to show you real quick that you absolutely know how to take care of those too. We have done a whole lot of converting grams to moles and moles to grams. So I'm going to do a quick example for you to remind you that you know how to do that. Okay. All right. So in that last problem, if you look at it, it says what volume. Okay. So I can already tell they're going to be looking for volume, right? What volume? I'm going to put my question mark here. Is occupied by. Now, what you have to realize when they give you grams, they're actually giving you moles. You just got to do a little bit of work. Okay. So 0.25 grams of O2. That's what they gave me, right? Grams of O2. You're going to have to set that up and do a quick conversion, grams of O2 to moles of O2. One, and it's 16. Oxygen's molar mass is 16, but there are two of them, okay? So it's going to be 32, all right? There are two of them. So you take 0.25 divided by 32. So it would be this divided by this, okay? And what you would get is 1, 2, 7, a little bitty number, and that's okay. Often moles are very small, so it's okay if you get a really small number. So basically, when they give you the mass, they are giving you the moles. You've just got to take a second to convert them, okay? It's at 25 degrees Celsius. I'm going to go ahead and plug that in here, and I'm going to immediately convert it to Kelvin to make sure that we don't forget. Okay, 298 K, and pressure is 100.66 kPa. You know, that's going to affect what R we pick, okay, because here we don't have an R. We're going to use the kPa-R, okay, it's right here, kPa. 8.314. All right, let's get it plugged in. Pressure is 100.66. We don't know volume. N is 0.0078, tiny. R is 8.314. We picked that one because it was in kPa. And then our temperature is 298. Go ahead and combine these. So 298 times 8.314 times 0.0078 would be 19.33. That is just all of these multiplied together, right? Equals. And then this is what you have left over here. So then you would just divide this over, away from your unknown, okay? So V equals 19.33 divided by 100.66. 0.19 liters. Volume is always in liters. Don't forget. All right. I know these last two problems I was dividing away this time both times, but remember in that first one we were solving for moles, and so I divided over this way. Just remember, you always divide away from your unknown, whichever way it is. Okay. All right.